analysis. This is not just memorization in your slides. It's understanding. Okay? So listen very carefully. Don't drift away. Don't go to the neighbor. You see, I forgot my water and soy sauce and my saliva is drying.
There's a vending machine outside. Would you like some water?
So do not waste my saliva. I'm okay if my saliva is wasted as long as you pass the exam. But if you don't pass, I feel bad. So my salivary glands stop. Anyway, okay. So the heart is in the thoracic cavity, not in the abdominal cavity. Okay. So usually it is in the middle, yes, at the mediastinum. So if you have the sternum, sternum, take it out, it's there. However, the apex of the heart tapers into the left. Why? Nobody knows.
There's no room here for the
Oh.
apex of the.
You have your lab.
We haven't touched the house yet.
I don't want to touch, but because you're not inquisitive. You
Is
have
it
to
because
ask.
there's no room here for the heart?
Why is your heart going to the left, not to the right? It's so the answer is so easy. Because of the space.
I just.
Your lungs, your right lung is bigger. There are 3 lobes. Your left lung is 2 lobes. Naturally, so the heart goes there. But however, there are people whose heart is just at the center. But it's okay, they're still alive, right? Even though maybe there are 3 lobes here, 2 lobes here, but generally speaking, that's how it is because this is bigger here than here. So it tapers to the left, okay, into the edge. So that's the main reason. Okay, so if you look here, mediastinum, you have this diaphragm on the abdominal cavity. So that's the left side, slightly left to the thoracic cavity, mediastinum, and superior to the diaphragm. So heart is posterior to the sternum, apex points to the left, okay, base on the posterior side of the heart. So you have that. So this is lateral view. So if you look lateral view, that's your mediastinum, then your sternum, your apex, your diaphragm, your base. Okay. So there are 4 hollow chambers in your heart. Okay. Right and the left. So 2 right, 2 left. So the upper one is right atrium. The lower one is the right ventricle. The left side is your left atrium, and the lower one is your left ventricle. Okay? 4 chambers. Okay? So in other words, left side, left ventricle, left atrium, right side, right atrium, right ventricle. Write it. So later, hey, you should memorize the flow of the blood in the heart. Because if you cannot memorize that, you will not be able to learn EKG, conduction system, cardiac cycle. Because in the end, we will have to integrate everything. But mainly, we need to study the structure of the heart and the flow of blood inside the heart. Mainly, okay? And understand it, not memorize it, okay? Okay, so superior right atria, right and left, lower is the ventricles, right? And then on the right, you have the veins on the right atria, okay? And then on the left atria, you have also the veins. So the veins on the left is the pulmonary vein. The vein on the right is your vena cava.
Yeah, vena cava.
Vena cava. Okay, write it. I'm going slowly. Yes. Okay. Inferior right and left ventricles that pump the heart through the arteries. Okay. So left atrium, right atrium, left ventricle, right ventricle. So you have that. Okay. Functions of the heart. So on the right side of the heart is the pulmonary circuit. On the right side, when you say pulmonary circuit, pulmonary means lungs, right? So on the right side of the heart, so the blood from the right side of the heart go to the lungs. That's your pulmonary circuit. So what is pulmonary circuit? Pulmonary circuit will be heart, lungs, back to the heart. Write it. So in this case, so the unoxygenated blood from the right side, because on the right side is, we say vena cava, right? Veins, vena cava, are the ones that bring blood from the tissues of the body, and they are not oxygenated. They have carbon dioxide, so they're called deoxygenated blood. When there is oxygen, we call it oxygenated blood. Okay, so that's the pulmonary circuit on the right side of the heart. Okay, so if you look here, that's the lungs, and if you look at the right side of the heart, it's blue because the blood is
Oxygenated.
deoxygenated, full of carbon dioxide, so it's blue. When it's red, oxygen, right? So we have red blood cells there. Okay, so that will be your deoxygenated, the heart. So you have this vena cava or vena cava, one superior, one inferior. So these are both veins. So this is superior vena cava and inferior vena cava going to the right atrium. Okay, so from the right atrium goes to the right ventricle and go to the lungs. That's why you have the pulmonary circuit there. Gas exchange occurs in the alveoli of the lungs. Okay. From there, if this is already your alveoli, so the blood has already oxygen, right? Because the oxygen comes from the lungs. So it will go to the left atrium, then to the left ventricle, and then to the aorta. Aorta is an artery. Aorta is the main and the largest artery that bring the oxygenated blood from the heart to all over your cells in the body. Okay? So that's the oxygenated blood. Now, so the gas exchanges and alveoli, of course, in the pulmonary capillaries, so the oxygen diffused in and then carbon dioxide diffused out of the blood, going so that you will exhale. So here, the veins of pulmonary circuit are oxygenated, so it is a little bit different, opposite. So when you say veins, it has oxygen in the pulmonary circuit. For example, so pulmonary artery is deoxygenated, but pulmonary vein is oxygenated. Because the definition of the vein and artery is, artery's main definition is vessel that go out of the heart, going away from the heart. And that's the definition of artery. And the vein is the blood vessel that will go to the heart. You know what I mean? So that when it is in pulmonary circuit, so the pulmonary artery is the one bringing the blood to the lungs without oxygen. It's carbon dioxide. The pulmonary vein coming back to the heart is the one already carrying the oxygen, but it's a vein. But generally speaking, a vein carries deoxygenated, artery carries oxygenated. So it's opposite. So don't forget that. So, okay, so we have that. Blue, we have that also. Now, to the circulation, to the body cells. So, if you look here, these are body cells, so this is systemic circuit. So, pulmonary circuit and systemic, right? So, where will it start? It will start with the red, because this red is the blood coming from the lungs, right? So, when it has these lungs, so this blood is going into the aorta. You see? Aorta, right? Aorta And our aorta is an artery, so it goes in a different direction in your body. So, oxygenated blood is pumped, gas exchange here, and then you have deoxygenated there. Okay? So, heart anatomy, layers. So, it is surrounded by a sheath called pericardium. It has fibrous, so it's called fibrous pericardium, very tough. It's very tough. So if you look here, there's a sheath covering the whole heart. It's really also protected, but there is also some fluid, pericardial fluid, just like your brain. So you have this cerebrospinal fluid, right? Okay, and the inner is your serous pericardium, which also has a big brain, which has a serous fluid. And then the serous pericardium will have two types, the parietal and the visceral. The parietal is out farther from the heart. The visceral is attached to the heart. So the visceral is called epicardium, which is the outermost layer of your heart. Because the innermost layer is called endocardium. Okay, so look here. That's the serous pericardium, which has two layers, parietal and visceral. Visceral is closer to the heart. The parietal is away from the heart. Visceral is, in other words, also called epicardium. Okay, and then you have your cavity, and then you have myocardium as the heart muscle itself, and endocardium is the innermost layer of your heart. It's all inside the cavity of your heart wall. Okay, so you have studied perivision, vision, and vision. It's almost the same, the words. Okay, so parietal will fuse to the fibrous, and visceral fuse to the epicardium. Okay, so if you put a fist here, like this, so it looks like a bag, and you put the heart inside the bag. So that's a serous fluid, and you see that in the serous epicardium. Okay, so here, myocardium is the heart muscle. So it's composed of fibrous muscle, mainly, and some of the fibrous skeleton in it. So the muscle is we call cardiac muscle cells, and it has some collagenous connective tissue. So in this case, we have the fibrous skeleton with cardiac muscle, and because it has to have something to pull on when the heart beats, it expands, shrink. So it can also insulate the heart when there's an electric signal. Endo is inside the lumen of the heart, or inside. So the lining is simple squamous epithelium. Okay, so that's your endo over there. You see that endocardium? Okay, so now let's go to the circulation. Coronary circulation is the blood vessels within your heart. Within your heart, okay? No, you have to gain more energy, huh? You're drifting away, so drink water. What can we do? We are here up to 10 o'clock, 10:15. Yeah. So, the coronary arteries are those arteries that will bring the blood to the heart. All of it. Okay? There is a right artery and a left artery. So in this case, it will arise from the aorta. Aorta is the big artery, right? That will bring blood outside from the heart. So in this case, you have marginal artery, you have posterior, you have anterior, and you have the circumflex. Now those are the major coronary. There's a drawing. This is anterior view. This is the right coronary. This is the left coronary. And this is the posterior view. Okay. The posterior view uses a complex artery there, so it will arise from the left coronary. If this is your coronary artery left, so somewhere here it will go posterior to become circumflex. Not in the right artery, huh? Not in the right coronary. So it is here. on the left side. So it goes, it twists to the posterior side. So in other words, the three big coronary arteries in your heart, one on the right side, one on the left side, and on the left side it will branch to the posterior, which is circumflex. Do you see this? It's very big. So in that case, everything fine, so your heart will beat normal. But if there's a lot of fat inside, so your heart will,
Oh, given.
okay? Okay, so here, with all those arteries that I mentioned to you, there is a corresponding vein, of course. The vein now is the one that will bring the blood unoxygenated or deoxygenated to the vena cava. Vena cava. Vena cava is always on the right side. So, great cardiac vein, small cardiac vein, middle cardiac vein, and then all of these blood without oxygen going back to the heart, to the lungs, is picked up by the coronary sinus. And coronary sinus goes to the right atrium to come together with superior vena cava, inferior vena cava, coronary sinus, then to the right atrium. Got it? Okay. So those are those veins. Great cardiac vein. So okay. Main great blood vessels in the heart. You have the superior and inferior. These are all the veins. Pulmonary trunk, pulmonary arteries, and the aorta. So that's the main aortas. So you know where the blood is going, right? So this is from the tissue, this is from the tissue, this is from the head, this is from the body, down. Pulmonary trunk is the one that brings to the lungs. Pulmonary arteries is continuation of trunk, then to the lungs. And then aorta is the artery coming from your left ventricle going to the body. Okay? So you have that. So superior drains to the deoxygenated to the superior to the diaphragm, inferior to the right atrium. So this big vessel is superior vena cava. This vessel here, inferior vena cava. So this vessel here is pulmonary trunk going to the lungs, and it will divide into two, right and left pulmonary arteries. And then this one is your aorta coming inside here to your left ventricle. So this is already deoxygenated, and this is deoxygenated, this one, going to the lungs. Okay? So on the other side, if you look again, so this is vena cava, so inferior, superior, and then you have your pulmonary artery coming from the trunk, and then you have your coronary sinus. Yeah. So the counterpart of coronary sinus is a complex artery. So pulmonary trunk receives oxygenated to the right ventricle, and then right and left pulmonary trunk bring deoxygenated blood to the right of the lungs. It divides. So it's the same. So this is the right coronary artery, left coronary artery, circumflex artery. Okay? And you go to the side, so this is your circumflex artery, coronary sinus, inferior vena cava, superior vena cava, right and left arteries, aorta. Okay? So then you have all of these and all of that, and aorta supplies the blood. And then the aorta, if you look here, it starts with ascending, and then aortic arch, and descending. So this is the aorta. It starts with ascending, and then arch, and then descending. So descending is pointing to the thoracic cavity, and then it goes beyond the diaphragm. When it penetrates the diaphragm, it becomes abdominal aorta. When it penetrates more to here, to the cavity, it will divide again like a Y to your right and your left leg, common ilia. So the end of your abdominal aorta is common ilia. Artery right, artery left. Then to the toes. Okay? Yeah. And then of course this one goes to the neck, base, everything. Here, there are three main here. This is brachiocephalic trunk. This is common carotid artery, and that's subclavian. It's the right and the left. Okay, so chambers of the heart. So, because we have 4 chambers, yes. So right atrium and the left atrium. We say that left atrium, the right atrium is larger and thinner, and left atrium also like thinner because it's so still both atrium. So there's a flap like here going all the way. So that one is the right, this is the left atrium. So if you open up, so that is the right and that is the left atrium. If we open up, so this is your right ventricle, this is your left ventricle. Then, because we're already in here, I'd like to explain to you the valves. The valves are very important from one chamber to the other to prevent what? Backflow, because they're just straight line going there, going here. So this is important for backflow, and then to build up pressure.
So that's why your heart pumps, right?
Correct, yes. Okay, so let's study now the valve. Because when we study now the valve, so we will already know the flow of the blood in your heart. Okay? So tricuspid valve is the valve that will separate the right atrium and right ventricle. And then we have the bicuspid valve here, will separate the left atrium and the left ventricle. So both of these are called AV valve, atrioventricular valves. Okay, that's the 2 valves. Another valve is called semilunar. So the semilunar valve, you have your aortic semilunar, because it goes to the aorta, and then pulmonary semilunar valve. Okay, then we call it semilunar valve. So 2 semilunar valve and 2 AV valves. Okay, so here we call it aortic valve, pulmonary valve, tricuspid valve, bicuspid valve, or mitral valve. Okay, so from that, let's see how we can get the flow of the blood. So I will very fast writing it. So now I will expect you to memorize it. Okay? Remember these, when I write here, I have allergy. If I cannot breathe, you have to take me to the hospital. Anaphylactic shock. But I will do this for you, so you learn. Okay? Do not waste energy. Okay? Right. On another page, if you cannot, you have to find the words. Okay. I will start with the blood going to the right atrium. Okay? So the right atrium, I will put the right atrium like that. Okay? So I will abbreviate. So the blood are vena cava, superior, and then inferior vena cava, and then coronary signs. So these are all veins. It goes to the right atrium. Now that's why I said you have to find IVC. Okay. If you cannot understand now, tonight, understand it. Okay? In your home. Okay. SBC, IVC, CS, and then right atrium, and then I go to the valve, which is tricuspid. Yeah? Tricuspid, this is an AV valve, atrioventricular valve. It goes to the right ventricle. It goes into the pulmonary trunk. Okay, not yet. Okay, it goes to the semilunar pulmonary valve. That is a valve. And then pulmonary trunk and then pulmonary artery, and then lungs, and then pulmonary vein. After the vein, left atrium, and then AV valve, bicuspid, and then left ventricle, okay, and then aortic valve, and then aorta. Okay, repeat. Study this, huh? Because if you don't understand this, the next cardiac cycle, the next EKG, the next conduction system, you won't be able to understand. When we study systole, diastole. Okay, again, this will come from the body. These are the veins that will bring the carbon dioxide to the lungs. Okay, so superior vena cava, inferior vena cava, coronary sinus. And then it will go to right atrium, and then there's a valve so that it goes to the right ventricle, tricuspid valve or AV valve, and then it now go to the right ventricle. This is going to the lungs, right? So there's a pulmonary valve, and then you have the pulmonary trunk, and then you have your pulmonary artery, lungs. Stop there so you can memorize. From the lungs, the blood is already oxygen, right? So with oxygen, so pulmonary vein goes to the left atrium, goes to the bicuspid valve or AV valve, goes to the left ventricle, and then goes to aortic valve, and then goes to the aorta. When it reaches aorta, now the blood is distributed all over the body. Pulmonary artery.
Yeah, but you said the valve to the trunk, then
Yes.
to the arteries.
Yes, to the lungs. So just look at the drawing. What comes first, trunk or valve? Of course, the valve, right?
Because I have a question.
That
This is a blood, like it makes a surface, right? As the blood goes out,
yeah, but this is like the extubation.
blood has to die too, right?
It goes out where?
Like from the body, like a sun.
It's already in your cells. In your cells. But this is the flow. What I wrote is the flow of the blood in the heart. In and out. Okay? Understand that? Because from there to normally have a good circulation, the amount of blood that comes into your heart should be the same amount of blood that gets out of the heart. Otherwise, there's some bottleneck somewhere, and goodbye.
It gets straight out.
Okay, so you got it? You got it. Who didn't get it?
So you say when it comes from the superior vena cava, goes to the right chamber, and then go get some oxygen, come back to the heart. Is that the
Yes.
flow? Come back to the heart and goes to the left chamber, and the left chamber is the one that transfers the blood to the aorta, and the aorta just go push.
Yes. But right now you don't say left chamber, only a right chamber. Because in the left chamber, there are two chambers.
So chamber, like right atrium, and then goes to the triceps.
Okay, so in general, the blood in the heart, in the right side of the heart, come from the tissues of the body. So in general, the blood come in from your left heart, come from your lungs. Why, Lynn? Why you look that way? Comprehended? No? You did not. Leah,
No, but I'm gonna read the book. I'm gonna read the book.
Okay, so like to point to you parts of the heart that you will memorize. Number 1, trabeculate carne. What is that? Number 2, pectinate muscle. What is that? Number 3, ligamentum arteriosum. Chorda tendinae. Okay. Number 4, papillary muscle. Okay. Number 5, interverticular septum. Number 4, ligamentum arteriosum. Okay, you know that. And then tricuspid valve, bicuspid valve. Yes, and you have that. And what else? Fossa ovalis. What is that? Fossa ovalis. Yeah. What is ligamentum arteriosum? What's fossa ovalis? Yeah, it's a lot. It's a lot to memorize. Okay? Okay. So one by one, we will study. So you don't have to worry. So what's pectinate muscle? It's very defined muscular ridges on the right atria. And then superior vena, you know that already, and coronar sinus. I wrote that. And the left atria is smooth and contains openings of pulmonary veins. You know that, right? That's a pulmonary vein. And the left ventricle is thicker and circular than the right. Why? Because the highest pressure should come from the left ventricle, because it's the one that pushes in the blood all to the aorta. The left ventricle is connected to the aorta, and your aorta is the one that brings the blood all over your body. That's why the thick muscle here is thick, needs pressure. Muscle is strong, right? Yeah, here. Look at the throat. Very thin. Right. So that's the rationale. Okay? You don't need a lot of pressure here because the blood flow passively to the right side. Here on the left, the blood has to be pushed so much to the aorta. So you need pressure. Big pressure on the left. Okay. So left ventricle thicker and circular than right ventricle, which is thinner and crescent shape. Why? I answered that, right? Okay. So right ventricle, left ventricle, right thinner, crescent shape, left ventricle thick, circular. Okay? Okay. So we know already. I said to you, what's trabecular carne ridges on both ventricles. What's chorda tendinae? Those fibers hanging. Valves between the atria and ventricles. What's interventricular septum? That wall separating two ventricles, left and right. Okay? Valves of the heart, you have two AV, interventricular, tricuspid, and bicuspid. Similar valves, pulmonary trunk and pulmonary valve and aortic valve. Okay? So, atrial valve prevents backflow between the atria and ventricles. Tricuspid valve has 3 cusps, that's why it's called tricuspid on the right side. And the bicuspid or mitral valve has 2 cusps, that's why it's called bicuspid, right? So this is tricuspid, this is bicuspid, so this is semilunar valve, aortic, this is semilunar valve, pulmonary. The way it closes and opens, we'll study later. That's why you need to know that. Okay. So attached to each cusp is chorda tendinae. Yes. Chorda tendinae is the one that pull, close, pull. Just imagine if one of your valves go crazy. What do you think? Your blood would do it like this, regurgitate. So you may have some murmur, arrhythmia, fibrillation, so many factors. Okay, so and then the papillary muscles of the tract. These are the ones that control the valve, closing and opening. Yes, this one. This is the chorda tendinae. That's the papillary muscle. Seminal valves prevent the backflow of blood from the pulmonary trunk and the aorta. Yes, these two. Okay, that's the one. So seminal is between right ventricle and pulmonary trunk. aortic Phillips here. Pulmonary femoral valve is between right ventricle and pulmonary trunk. Okay? And aortic femoral valve is between left ventricle and aorta. Okay? So that one is the aortic valve, that is your pulmonary valve. So femoral valves do not attach to chordae tendineae or papillary muscles. Look again. Yes. No tendinate, no papillary muscles. They're just like a plump on the two valves, big valves. Okay, so this is true to life. There's just laparoscopy. They put the light, so you pulmonary valve closed, pulmonary valve open. So big picture of the blood flow.
Oh, nice.
Actually, this is very easy. It's not misunderstanding. So you always start with systemic capillaries without oxygen. So that's a systemic vein. You have the vena cava superior, vena cava inferior, and then always the vein from the heart. You don't forget this coronary sinus. Yes. Some students always forget coronary sinus. I don't know why. So, but your blood, your heart, has to have its own blood supply. Okay? So then you have that systemic return to the right atrium. Then passes into the tricuspid valve to the right ventricle, and then it passes into the pulmonary valve and trunk and artery, then to the lungs. And then you have the right ventricle that pumps here, right? And the pulmonary trunk go into the lungs, and then the blood go back to the heart by pulmonary veins to the left atrium, yes, and then there's a bicuspid valve from the left atrium to ventricle. So the left ventricle pumps blood to the aorta, okay, and then to the systemic circulation. So you have that. 2 slides. Okay, I think we have this. It is easy for you because we studied very hard the muscle contraction and the muscle structure in the skeletal muscle. There's just a little difference. Like for example, it's a branch cells shorter and wider. It has the myoglobin, which is the cells, have many more mitochondria, and it has intercalated disc. That's the difference between your muscle tissue, right? You have your sarcomere, your H band, A band, different line, you have those zone of overlap, and so on and so forth. It's the same, except for the intercalated disc, because it bonds together the muscle fibers. You don't have that in skeletal muscle, okay? So that one, it bands together the cardiac muscle intercalated. That's why when the cardiac muscle excites, the whole of the cardiac muscle excites, not motor unit, which is like in the skeletal muscle. Okay, so cardiac electrophysiology. Okay, I will try to skip because we have known this already. With the voltage gating channels, the sodium channel, the calcium, the potassium. This is just the difference. This number 3, plateau phase, because in the muscular tissue, in the muscle tissue, we don't have the plateau phase. So what is this plateau phase? So the plateau phase, because the blood in the heart goes from one chamber to the other, so it allows the blood flow to pass by the valves, and in a slow manner. At the same time, the calcium also gets out very slowly, so that there is time for the right and the left chambers to wait for the flow of blood, and at the same time, there has to be no tetany. You know tetanus? Tetanus, they're gonna twitch. There should be no twitching on the heart. So we avoid that. That's why there is a plateau. The refractory period is very long compared to the muscle tissue. Okay, so if you look here, we know this already, this repolarization.
So this is not gonna be on the test. So we already did
Why
it.
not? Ah, that's why I'm giving you the difference only. I'm not giving you the same muscle tissue that I give you today. It's the same, except for, listen to the except for. So that is the exam. Okay, so here depolarization, the same, minus 85, it becomes 30, right? So instead of that, and then we have the initial repolarization, it's the same. This is the one that has
Plateau phase.
I think what she's asking is the other phases going to be on the exam as well, or just the plateau?
this difference. I will let you differentiate the muscle, conduction, skeletal, and this. So that's why I'm showing you how it looks like. So you see this refractory period, this time period, and the plateau. And the plateau. Do you know how your skeletal muscle is like this, like that, right? If you look again, in the diagram. So the pattern is so different. That period allows the blood to flow from one chamber to the other, especially from atria to ventricles. Yeah, so that's the main difference. So look at the main difference. Okay, so the same with the channel, only that the difference that calcium flow is very slow. Okay, so here, comparison, cardiac action percent are much slower than the skeletal. So if you remember these, reduction potential, it's rapid. But in the cardiac, you see these goes like this and then go down. So depolarization, refractory period, and then repolarization in the cardiac. In the muscle tissue, depolarization, then rapid repolarization. What did I say? What's the reason why? To allow the heart muscle to beat rhythmically. Because the rhythm of the heart, the beating is a rhythm. It's rhythmic, autorhythmic. So from the start of the signal of the action potential, we reach into the ventricle. It goes to the ventricle, it goes into the Purkinje fibers on the left ventricle. So when it's already up here on the left ventricle and right ventricle, that's a sign that the force is very strong. Okay, so excitation coupling the heart. So the majority of the calcium is at the extracellular fluid, while in the muscle tissue, the calcium comes from the T tubules. Remember? Exams. So this is. And then you have this also these transverse tubules, then you calcium, and there's the voltage channel. So it's the same as in your muscle. The big difference also is we don't have NMJ, you remember? Neuromuscular junction, the terminal axon, we don't have the acetylcholine in there. Instead, we have the pacemaker cells coming from the right atrium. So that's why heart is autorhythmic. It doesn't need NMJ. Okay, so that's the cardiac conduction system. So you have also the resting membrane potential is the same. Slow depolarization, full depolarization, and then the minimum potential, which is almost the same as the muscle. Okay, so now after what we have learned from there, so we have to know how the heart beats. That's the conduction system. So there are this system. For example, the autorhythmicity, the start of the heartbeat comes from there. This one is a node. So say sinoatrial node. Where is that? the right atrium, okay? Just right atrium. So here, if this is working properly in your heart, you have normal heartbeat. What is your heartbeat normally?
Love though.
That is not heart.
The range?
Are you very philosophical?
No, that's what I said, love though.
How many beats per minute you have?
60 to 100? Is it 60 to 100?
Huh?
Is it 60 to 100?
100, you already talking
I mean
about
12? I mean, you mean the heart rate, is it 12? Is it between,
heart rate.
okay. Are you talking about
Heart rate
pulse
and
or
heartbeat are the
pulse?
same.
Okay. Are you talking about
I'm talking about the heart rate.
the rate? Is
Because
it
we're talking
12?
about the contraction of the heart, yes.
Is it 20? Between
Oh my God. You're dying if you're 20.
Okay, I just said 60. You
I don't
said
know.
no.
Every 2 seconds, it's one time.
No problem. 6 a little bit lower.
Is it 60 to
77.
What's in your book?
Is it between 60 to what?
I don't know. So we tired, like.
Your SA node is not. Oh, when you're tired, nobody can control you except yourself. Go home. But I will still stay here and talk.
60 to 80 cardiac cycle.
6 to 20, let's say 75. Okay, so if this is working, you will have a 75 beats per minute. If this is not working, so your AV node will work. Will start the beating, but it is lower. If this is not working, this one will, but you will have a 20 beats per minute. You may have here 45 beats per minute. This is not enough. This is the normal. Got it? Okay. So, okay. You call that ectopic. It's not ectopic pregnancy. Ectopic pacemakers. Still, your body is really good because if that place is not working, the sinoatrial node, so you still have reserve. But it's not enough. You have to go to the doctor and get a pacemaker battery. Battery.
But they want to do like a one every 10 years.
15 years, 10 years, 5 years, depends on what type of battery. Yeah. Anyway, okay. So that's the SA node. So 60 action potential per minute, good. And then it is autonomic. So that's the place. Okay. So again, when people have very weak heart, so the doctor inserts. It's like a pouch. They insert the pacemaker. That's why this is called. SA node is called pacemaker of the heart. Okay, and then AV node, there is also a conduction system then, and then the Purkinje fibers. So that's the action potential for either. But if you look here, if it is from here, it's 40 action potential, very slow. Okay, and the last is the Purkinje. It vaporizes 20 times per minute, not enough, right? And then if you have these, AV node, right, one node pulses and terminal, so not so good. So what happens here now is terminal branches goes, and then what happens now if this is not functioning so well, so that you have what you call irregular heart rhythms called ectopic pacemaker. That is the time when somebody needs artificial. Okay, so that's the pathway. Okay, again, count the conduction system. Number 1, you have the SA node. Number 2, AV node, and then it goes into interventricular subtube, reaches the Purkinje fibers. This is the action potential. So when the action potential is here, this is contraction of the ventricles. This is what you call systole. Systole is contraction. Diastole is relaxation. So there are an alternating diastole asserts systole. So if the ventricles contract, atria relax. If the atria contracts, ventricles relax. At the same time, left and right. At the same time, left and right. Okay? Okay. Yes. That's how it is. So up to that, work with your fibers. Clear issue.